Hello, Harsha and Yasir, am I audible? Yes, Harsha
Yes,
and
sir.
Yasir. So in the last lecture, we looked at dipole moment at the end. And there is last topic that we have to discuss, that is resonance. Okay. After that, we will move on to molecular orbital theory. Fine. So write the topic. Resonance. Now, understand about the resonance in chapter that is some basic principle and techniques of organic chemistry. Organic chemistry, some basic principles and techniques. So in that, we will look at the resonance concept in detail, and it is used, I can say, very much in organic chemistry, the concept of resonance. But basic part that you have to understand here is, please write, when one Lewis dot structure is not able to represent complete properties of a molecule, then its resonance structure is drawn. Resonance structure is drawn. Okay, its resonance structure is drawn. Okay. So right next. Now this phenomena, the phenomena in which properties of a molecule is represented by more than one structure is called resonance. It's called resonance. Okay. So, Mariam, you don't write this part. Okay. You will start writing from molecular orbital theory. Fine.
Okay, sir.
Just
okay.
5 more minutes and then we can start writing. Okay. Let me know if everyone is done writing.
No, sir. 1 second.
Okay. Fine.
Okay, sir. Done.
Okay. See next. Okay. For example, if you see the structure of, see here. For example, the structure of ozone. So ozone has a double bond oxygen like this and a single bond oxygen like this. Okay. Now, the double bonded oxygen can be on the right and the single bond can be on the left. This is also ozone. Okay. Now, when both of these structures, when you are going to write both of these structures, then only you are representing what? Then only you are representing the complete properties of ozone, the complete properties of ozone. And what I can do, I can take both of these and make a resonance hybrid. So this is resonance happening, and I can make a resonance hybrid structure. So I will make single bond oxygen, okay, and partial double bond between these two oxygens. So this is known as resonance hybrid structure. Resonance hybrid structure. All of you got this? Yes or no? Please tell me. Okay, so please write. The actual structure, which is made by all the contributing structures and represents all the properties of a molecule is called resonance hybrid structure. Okay, resonance hybrid structure. The contributing structures are called structure or canonical structure. Or canonical structure. Is everyone done writing this? All of you done writing?
Yes, sir.
Yes, sir.
Now, please see, for example, we'll look at two more examples. Let us suppose we have sulfur trioxide. So in this, if you make the structure, it will be sulfur double bond O, and the other oxygen will be single bond O and single bond O, SO3. Now, we can write the resonance hybrid structure as so here we have three oxygens, right? So in the first case, the top one is having double bond. In the second case, we can have a double bond in the left one. And then we can have a double bond here also. Right. So all of these are what? All of these are resonance structure or canonical structure. But the resonance hybrid structure that will be made by the all these contributing structures, it will be sulfur with 3 single bond oxygens, and all these bonds will be having partial double bond character. The basic idea is you look at the sulfur. Let me make this atom 1, oxygen 2 and oxygen 3. So if I look at sulfur and oxygen 1, it is sometimes double, single and single. That means it is not always double bond. That is why a partial double bond. Similarly, sulfur and second oxygen, single, double, single. So it is not always single, neither it is always double. So it is partial double, and similar is the case for the third oxygen also. All of you got this? Yes or no? Please tell me.
Yes, sir.
Yes, sir.
Okay. Now, second, let us suppose you have CO3 2 negative. So here also the same thing is happening. You have carbon atom with double bond oxygen, oxygen and oxygen. And here it is having, I'm just giving 2 negative charge here like this. Now, if you see this part, and then what you can draw, you can draw 2 more structures, right? Now, this will be completely 2 negative. Okay. After this, you will write characteristic of resonance. Then we will move on to molecular orbital theory. Characteristics of resonance. Please write number 1. The contributing structures do not have real existence. Do not have real existence. Resonance hybrid structure as real existence. Second point. Because of resonance, the bond length of resonating structures, this is resonating structure, bond length of resonating structures become equal. So for example, all CO bonds in CO3 2 negatives are equal. Both oxygen bond in O3 they are equal. Similarly like this. And the third point. Resonance hybrid structure has lower energy and hence high stability. Because there is delocalization of charge, the electron is moving, and if you have electron in a larger area or any charge in a larger area, that will be more stable. Hence high stability, you can write due to delocalization of pi electrons. Right, the fourth point. While making resonance structure, only pi bond is moved. Only pi bond is moved. Sigma bond and the atoms remain as it is. And last point. Resonance is a theoretical concept. All of you done? Please tell me.
Yes, sir.
After this, write the heading molecular orbital theory. Molecular orbital theory. ठीक है? See, the basic idea of molecular orbital theory is very simple, है ना? बहुत ही ज़्यादा simple है. Molecular orbital theory कहता है that in atoms, electrons are in. कहाँ पे होते हैं बताइए जरा electrons? Where can we find electrons in an atom? Harsha, Siddika, Yasir, Alia, Maryam, Abdullah. Where
Orbitals.
can we find the electrons? जोर से थोड़ा सा हर्षा.
Orbitals.
Orbitals, very good. So in atoms, electrons are in atomic orbital. कैसे orbital? Atomic orbital. है ना? And very simple idea. In molecules, electron are in molecular orbit. Easy है हाँ या ना? The first principle of molecular orbital theory is very plain and simple. Yes or no? Please tell me. हाँ जी बताएं.
Yes.
ठीक है. Now moving on slowly and slowly. Molecule is made by atoms. Correct guys? Yes or no? Please tell me. Molecule is made by atoms. Yes or no? अरे बोलो भाई.
Yes, sir.
Yes. So molecular orbitals will be made by
Atomic orbitals.
atomic orbitals, है ना? हमने नहीं, हर्षा की थ्योरी. ठीक है ना? This is very easy. Okay, molecular orbitals are formed by, so obviously atomic orbitals are going to combine, so they combine in a very linear fashion, are formed by linear combination of atomic orbitals. वो बोलते हैं LCAO, linear combination of atomic orbitals. Okay, so see, we completely know everything about the atomic orbitals: 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, right? And all of these things. So we have, then we can plug in the electrons and get the electronic configuration of each and every element. So right now what we are going to do, we spent time on the subshells 1s, 2s, and the further subshells. Similarly, we have to spend a bit of time to understand the molecular orbitals. And you guys have only said that molecular orbitals will be formed by the combination of what? Atomic orbitals. So first of all, we'll understand the molecular orbitals and how atomic orbitals combine to form molecular orbitals. Then we can easily deal with the different molecular orbitals, and then we can plug in the electrons also there. Okay, chalo. Please see, first of all, write the topic linear combination of atomic orbitals. Combination of atomic orbitals, linear combination of atomic orbitals. Okay. Now there is a basic difference. There is a basic difference between those who have learned with me the valence bond theory and the molecular orbital theory. Okay, valence bond theory and the molecular orbital theory. And that difference is, for example, if I take the S subshell, this is S subshell of an atom A, and I have the S subshell of atom B. I have the S subshell of atom B. Both of them are having opposite spin electrons. Both of them are having opposite spin electrons, and then they are going to combine to form a molecule AB. Now, if I go through the VBT approach to understand the molecule, then I have to do the overlapping of orbitals. I have to do something like this, that the atomic orbitals are overlapping and the electrons are getting paired like this. Okay, but if I talk about the linear combination of atomic orbitals, then the situation is a bit different. Situation in MOT is that these orbitals are getting combined in what type of fashion? In omelette type of fashion. Okay, so this is the MOT part. As you can see, when you see the VBT overlapping, then you can completely say that this is one S, this is S orbital, and the other one is also what? S orbital. That means they are maintaining their identity. The atomic orbitals are still having their identity. And you can say that it is like making a sunny side up omelette, a sunny side up egg with 2 eggs. Yes or no? So you can see both the yolks completely. Correct, guys? Yes or no? Please tell me. If you are making sunny side up with 2 eggs, then you can see that, okay, fine, there are 2 yolks and it is made by 2. But molecular orbital theory, here what happens? Here the combination happens. And due to combination, you can give an analogy of omelette. The complete identity of egg is demolished. You can't even say that how many eggs were present and what type of egg was present. But in sunny side up, you can easily see the yolks and you can say, okay, 1 egg, 2 egg, and so on. All of you understood this? The difference between VBT and the MOT? Hanji, बताएं. Guys, tell me, Mariam, Harsha, Alia,
Yes,
Yasir.
sir.
Yes, na? So omelette and sunny side up. All of you know, na? Sunny side up. Hanji. All of you guys know what is sunny side up? Yes or no? Sunny side up नहीं पता किसी को? जो पलटी बोलते हैं, पाउच बोलते हैं, कुछ बहुत सारी चीजें बोलते हैं ना, सनी साइड अप नहीं पता. हाँ, मरियम, you know what is sunny side up? How to?
No, sir.
नो यू गाइस डोंट नो व्हाट इज सनी साइड अप, इसको क्या बोलते हैं फिर आप लोग? हम तो इंग्लिश बोल रहे हैं, अपना यहाँ देसी लैंग्वेज बोल नहीं रहे। सनी साइड अप guys, this type of egg is known as sunny side up. So क्या बोलते हैं आप लोग? मरियम, what do you call this type of egg? Yes, Mariam.
I don't call it anything.
You don't call it anything. मान लीजिए आपको ये खाना है, ऑमलेट नहीं खाना है, तो फिर क्या बोलिएगा, क्या ऑर्डर कीजिएगा?
I don't
Okay,
know.
guys, you don't know. What about Siddika, Harsha, Yasir? Siddika?
Sir, I knew what the sunny side up egg was.
Sorry?
Sir, I know what it is.
अच्छा,
The
you know
sunny
what
side
it
up.
is. So this is sunny side up. Okay, इसको अगर बोलना है, अगर आप कोई फाइन रेस्टोरेंट, फाइन डाइनिंग, अगर आप इंडिया आए तो इंडिया में इसको बोलते हैं पाउच, या बोलते हैं इसको पलटी। ठीक है? Pouch is also not exactly this, according to the Britishers. Pouch is something that you make in boiling, not boiling, but I think simmering water, and you add egg on simmering water, and then you just roll that particular water. So it becomes pouch type of thing. Fair. Moving on. So basic difference is what? If you have not written this, please write this down. The basic difference between VBT and MOT is right. In VBT, atomic orbitals maintains its identity, maintains its identity. In MOT, atomic orbital loses its identity. Now, write next. Write some remarks. There are remarks before the linear combination of atomic orbitals. Remarks. Right. Molecular orbitals are formed by linear combination of atomic orbitals of two atomic orbitals. ठीक है? When we are combining atoms, or when we are combining the atomic orbitals, we can only combine two atoms. We can only combine two atomic orbitals. Next point. Number of molecular orbital formed will be equal to number of atomic orbital getting mixed or getting combined. Rather, I should write combined. Okay. Now, once you have written this remarks and all, ध्यान सुनिए, है ना? All of you keep your pens aside. Anyone still writing? Anyone
Yes,
still
sir.
writing? Acha, Siddika, please write. Let me know once you're done, and then leave your pen aside. Done, Siddika?
Yes, sir.
Okay. Now, please leave your pen aside. Don't write anything. Okay. If I take the s orbital, if I take the s orbital. So what is the shape of s orbital, guys? Tell me. What is the shape of s orbital? What is the shape of s orbital? Oh, किसी को नहीं याद? हर्षा, सिद्दीका, मरियम, यासिर, आलिया, अब्दुल्ला. Shape of s orbital. क्या ही फायदा भाई पढ़ाने का. हर्षा, यासिर, मरियम. Yes, यासिर correct. Mariam, what is the shape of s orbital?
Sphere.
हाँ, spherical shape. Okay.
Yes.
What happened, guys? सिद्दीका, आपको नहीं पता? भूल गए आप? हाँ सिद्दीका.
No, sir. No, sir.
फिर ठीक. Now, so the s orbital can be of two different phases. अगर आप लोगों को याद हो, that the shape that we get is because of the shape that we have, and then we have a phase of those orbital. है ना? Now, s orbital can be of two types. S orbital can be either, it will be spherical in both the cases, but it can either have a positive phase or a negative phase. It can either have a positive phase or negative phase. Okay, positive phase or negative phase. Now, don't write anything and try to understand. Let us suppose we are talking about hydrogen atom. Let us suppose we are talking about hydrogen atom. Now, there will be millions of hydrogen atoms, right? And these hydrogen atoms, they will combine, one hydrogen and other hydrogen atoms. They will combine with each other to form hydrogen gas, that is H2. Hydrogen gas, that is H2. Now, when the hydrogen atoms are combining, actually their orbital is combining. And what orbital? Because hydrogen has electronic configuration 1s1, we have only the 1s atomic orbital which is going to combine, and the 1s atomic orbital, half of them, according to the probability, half of them will be in positive phase, half of them will be in negative phase. That means there are two possibilities while combining. When the combination of atomic orbitals are happening, there are two different possibilities. Phases can be same or phase can be different. सही है guys? Yes or no? Please tell me. हाँ जी बताएं. मरियम, यासिर, सिद्दीका, हर्षा. Any doubt here? Alia and Abdullah?
No, sir.
No, na? While combining, the phase can be same or the phase can be different. Phase can be same and phase can be different. Now,
So phase in the sun sign.
if you remember phase, this is phase ना? Positive phase है या negative phase है. ऊपर हुआ तो positive, नीचे हुआ तो negative. If you remember, so see, all of these atomic orbitals are from the wave function psi, है ना? So psi represents the wave function and it is a wave. So wave will be either having positive phase or negative phase. Got it? Harsha, remember this? ठीक है, चलिए. Now, don't write anything. Now, since we are talking about S subshell, so let us see if there is a positive phase S subshell like this. ठीक है? And there is also one more. This is also positive phase. ठीक है? So both of these are combining. इन दोनों को क्या करेंगे हम? We will add them. So when we are going to add them, so see here. This part is going to get added by this part. This part is going to get added by this part. This part is going to get added by this part. And this is going to get added with this part. Right? So each and every point will be added to this. And what we are going to get is double the length. Yes or no? Please tell me. हाँ जी बताएं. कुछ बड़ा सा मिलेगा, हाँ या ना? बात समझ में आ रही है? सोनू बिसलमी, मरियम, आलिया,
Yes, sir.
Yes, sir.
ठीक है. Now let us talk about the different phases. इसी को लेके चलते हैं उधर, है ना, और इसको कर देते हैं उल्टा, फ्लिप वर्टिकल. अब बताइए, let us suppose this is +2, this will be -2, 3 -3, 4 -4, then again it will be a bit down, तो इसको 2 कर देते, ये -2. Now when you are going to add both of them, then what you will get? You will get nothing. All of these are cancelling each other out. Yes or no? Please tell me. Correct है?
Yes, sir.
ठीक है, चलिए. Now please remember, what are these? These are s orbitals. These are s orbitals, which we are just adjusting a few things. Okay, just trying to understand what is actually happening when we are having same phase and different phases. The s orbital wave will not be exactly like this, but the properties that we are talking about addition, doubling, and cancellation will be the same. And essentially, the properties that we are talking about addition and cancellation will be same, because the main idea is same phase and different phase. When we are having same phase, obviously it is going to get added, no matter how the graph is. Let the graph be like this, है ना? Or let the graph something like this, then also it is going to be get added, right? Now, please understand, we are talking about the S. We are talking about the S subshell. We are talking about the S subshell, hydrogen atom. S subshell, hydrogen atom. And these waves are psi. These waves are, let us suppose this is psi A and this is psi B. Psi A and psi B. Okay, psi A and psi B. And this, whatever resultant we have got, it is after the combination of A and B. So this will be psi AB. This will be psi AB. Any doubt till here? Siddiqa, Yasir, Mariam, Abdullah, Alia. Tell me, guys.
No,
No,
sir.
sir.
ठीक है. अब बहुत इंपॉर्टेंट बात है, ध्यान से सुनो, ठीक है? Those who have done atomic structure with me, you would remember that psi does not have any physical significance. Psi does not have any physical significance. Psi square has physical significance. What has physical significance? Psi square. Now, when the combination is happening, we are having psi AB, which is equal to psi A plus psi B. Psi A plus psi B. And when we are going to square it, psi square AB, this will be equal to psi A plus psi B to the whole square, which will be equal to psi square A plus psi square B plus 2 times of psi A and psi B. Is this clear? Yes or no, please? Clear, guys? Yes or no? All
Yes,
of you guys? ठीक है. Now, when we are squaring anything, so essentially psi square A and psi square B is expected, है ना? If I squared individually these things also, we would have got what? We would have got psi square A and psi square B. But because the combination is happening and then there is a squaring, combination is happening. See, important part kya hai? If we were to take the square of these individual atomic orbitals, you would have got only psi square A and psi square B. But when we are combining, we are getting an extra element of 2 psi A psi B. We are getting an extra element of 2 psi A psi B. And what is psi square A and psi square B? It is the probability of finding electron. Finding electron. Now, please see what happens here. When you combine both of these, we have atom A and we have atom B. Here is the nucleus of atom A. Here is the nucleus of atom B. And when both of these atoms, their atomic orbital combine, there is a large electron density, as you can see here. See, this large electron density is present. And this is only psi AB. We are going to square it. And between the nuclei of 2 atoms, there will be a large electron density. Large electron density. When there is a large electron density, this nucleus will be positively charged because nucleus has proton and neutrons. Proton is positively charged, so nucleus is positively charged. This atom B is also positively charged because nucleus has protons and neutrons. Protons are positively charged. and the identity of any element lies in their nucleus. Hydrogen is hydrogen because it has one proton. If the nucleus of hydrogen had two protons, it would have been helium. So the identity of atoms, it lies in nucleus, and the nucleus of A is attracted in this direction because here we have electron density. The nucleus of B is attracted in this direction because we have electron density. And we can essentially say that atom A and atom B are attracted towards each other, and this is nothing but this is a bond. This is a chemical bond. All of you guys understood how the concept of chemical bond comes from molecular orbital theory? Yes or no? Please tell me.
Yes, sir.
What about others? Mariam, Yasir, Siddiqa. So I will tell you once again everything with thoda slowly. It was a very long lecture. Now we will get some links. Atomic orbitals combine. Atomic orbitals combine. Then what happens? Then electron density between atoms increases, and after that what happens? After that the bond is formed. Now one more thing, this is only the story when we have same phase. When we have same phase. Now if the phases are different, then what happens? There is no electron density, right? There is no electron density. And because when we are having same phase, a bond is formed. What is formed? A bond is formed. That is why this type of, see, combination of atomic orbitals give rise to molecular orbital. This molecular orbital is responsible for bond, Therefore, this is known as, this type of molecular orbital is known as bonding molecular orbital. And when you have atomic orbitals in different phases, when they combine, they give rise to no electron density. There is no electron density here. It is completely cancelled. And that is why this is known as anti-bond or anti-bonding molecular orbital. थोड़ा समझ में आया सबको? हाँ या ना बताएं? हाँ जी. Guys, tell me, Mariam, Yasir, Siddiqa, Harsha, bonding molecular orbital, anti-bonding molecular orbital. Yes or no? हाँ जी.
Yes, sir.
ठीक है, पक्का. चलिए, इतना अगर नहीं समझ में आए तब भी कोई दिक्कत की बात नहीं, कोई आपसे पूछने नहीं वाला है इतना. ठीक है, बट स्टिल इट इज वेरी एसेंशियल टू एट लीस्ट हियर इट वंस so that you understand what is actually happening. ठीक है, so right next लिखित में कर लीजिए इसको, please read. Formation of molecular orbitals. Formation of molecular orbitals. Just give me a second, guys. Right, number one. Just a second. Right, number 1 point, the first point. molecular orbitals are formed by combination of atomic orbitals with of same energy, or with or say of same energy, okay. So the energy difference between those orbitals should not be very large, it should be almost same. Right, the second point, as we know, when एक चीज हमने लिख लिया, number of molecular orbitals formed will be equal to the number of atomic orbitals involved in the combination. Okay. Right, next. Second, half of the molecular orbital formed are by combination of atomic orbital with same phase. Atomic orbital, combination of atomic orbital with same phase. They give rise to bonding molecular orbital, which is lower in energy, which is third is half of the MO formed are by combination of atomic orbitals with different phase. They give rise to anti-bonding molecular orbital, which is higher in energy, All of you understood this? Yes or no, please tell me.
Yes, sir.
Yes, sir.
इतना समझ में आएगा सबको? ठीक है. Now we are going to look at the different types of atomic orbitals and how they form molecular orbitals, है ना? उससे पहले बस थोड़ी सी बात ये लिख लीजिए कि psi A plus psi B give rise to psi AB, and this is bonding molecular orbital BM. ठीक है, उसी तरह से psi A plus I'm writing minus psi B. It doesn't mean that one is positive phase and the other is negative phase. It just means that both of them are having different. यहाँ पे भी जब हम बात कर रहे हैं ना, तो both of them can be negative also. Both of them can be positive also, है ना? So we are talking about same phase and different phase. Negative कोई बुरी चीज नहीं है. Here, negative is not a bad thing. If you have negative and negative, then also it is good. If you have positive and negative, then it is a bad. Whether you have negative positive or positive negative, ठीक है? Negative is also good. Bonding molecular positive is also good. ठीक है? चलिए. Next, you write. This will be known as psi star AB, and this is anti-bonding molecular orbital. Anti-bonding molecular orbital. ठीक है? बढ़े आगे. Right, next. LCAO, linear combination of atomic orbitals of different atomic orbitals to form molecular orbital. To form molecular orbital. ठीक है, चलिए सबसे पहले देखते हैं हम लोग एस एस की कॉम्बिनेशन, है ना, 1s और 1s। देखिए गाइस, one S and one S. Okay, so all of you please see this and don't write anything. This is your 1s orbital. This is another 1s orbital, and let me just mark the nucleus here. This is the nucleus. This is the nucleus here. ठीक है? Now, so obviously both of them can go into two routes, है ना, subtraction and addition, है ना। subtraction तब होगा जब आपके पास different phase हो, जब addition तब होगा जब आपके पास same phase हो, है ना। So when I say subtraction, that means different phase. Addition means same phase. So just a second, let me get it white, copy and paste, and I need to rotate this. ये rotate नहीं होगा क्या? होगा ना भाई? Rotate नहीं होगा ये, क्या बदतमीजी। बढ़िया फिर यही करते हैं। Just be patient, guys. ठीक है, प्लीज सी। लेट अस सपोज वी आर डूइंग, यहाँ पे आपके पास डिफरेंट फेज है। जब डिफरेंट फेज होगा देन इट विल बी सब्ट्रैक्शन। हियर वी हैव सेम फेज, तो होगा एडिशन। ठीक, सेम फेज में एडिशन और डिफरेंट फेज में क्या हो जाएगा, सब्ट्रैक्शन हो जाएगा। ठीक है, नाउ प्लीज सी, डिफरेंट फेज, इन दोनों को हमने ले लिया, कॉपी पेस्ट कर लिया। एडिशन पहले कर लेते हैं इनका। जब सेम फेज था तो दोनों इस तरह से बिल्कुल ठीक है। ठीक है जी, अच्छा। नाउ व्हाट विल हैपन, बोथ ऑफ देम विल मिक्स एंड दे विल forget their identity, and now they are molecular orbit. ठीक है, and as you can see there is a lot of electron density here. ठीक है, there is a lot of electron density here. Now they combine completely, और जो essentially the shape that they get is something like this. They combine, इस तरह से combine करते हैं, and the shape that they get is in between they have a lot of electron density, and this is also in white, and इसके nuclei यहाँ। Okay, so here it is the nucleus. Okay, so this is electron density in between, and this is bonding molecular orbital. ठीक है, now when there is anti-bonding molecular orbital, then what is going to happen, please? Also one more thing here I can write, both the having same phase, plus plus या minus minus है, plus and plus phase। ठीक है, और जो यहाँ पे the anti-bonding molecular orbital, so here you have the nucleus, and here is the nuclei of other atom, and there is no electron density, meaning minimum electron density between both of them. Okay, so cancellation happened now, that is why there is no electron density here. Copy paste, and I will flip this up. Okay, flip horizontally, and I will just place this here. ठीक है, so I hope now you get that there is no electron density here. Can all of you see that? Yes or no, please tell me.
Yes, sir.
What about others?
Yes, sir.
ठीक है, there is no electron density here. So obviously they will be having different phases. So one positive and the other one will be negative. Got this? Yes or no? Please tell me. हाँ जी बताएं. Tell me guys, all of you got this? Yes or no? Please tell me. बोलो भाई.
Yes, sir.
ठीक है. Thank you very much. Now, see, this was the axis in which the nucleus, then both the nucleus were lying, and in the same axis they were moving, and then they combine. So the axis in which both the nucleus lie is known as internuclear axis. Internuclear axis. If the bonding is happening on internuclear axis, if the combination is happening on internuclear axis, then the bond formed is known as sigma bond. It is known as sigma bond, and that is why this is sigma bond made by 1s. Got it, guys? Yes or no? Please tell me. Which will be a bonding molecular orbital. Now, when you are having anti-bonding molecular orbital, this will be sigma star, as we have seen. Anti-bonding में star लगेगा, and it is made by 1s. So this is sigma star 1s. This is ABM. Got it, guys? Yes or no? Please tell me. ये दोनों बातें समझ में आई सबको? सिग्मा स्टार एंड ABMO एंड BMO. मरियम, यासिर, सिद्दीका, अब्दुल्ला.
Yes, sir.
ठीक है, तो
Yes, sir.
मेहनत, ओके, आई मीन द मेहनत इसी में है, ठीक है ना. इस वजह से आई एम टेकिंग अ लॉट ऑफ टाइम. रेस्ट ऑफ देम आर गोइंग टू बी वेरी सिमिलर. सबट्रैक्शन एडिशन ही तो है. रेस्ट ऑफ देम आर गोइंग टू बी वेरी सिमिलर. दैट इज व्हाई आई एम नॉट गोइंग टू स्पेंड एज मच टाइम देयर. अब थोड़ी थोड़ी चीजें हम लोग दोनों इन BMO और ABMO के बारे में देख लेते हैं सर. ठीक है, प्लीज सी हियर. If you see this BMO, if you see this BMO, it is completely symmetrical, है ना? It is completely symmetrical. अगर किसी को अनसिमेट्री दिख रही है तो फिर वो बताएं. This is completely symmetrical. Now it is also, it is forming a bond, है ना? That means nucleus के बीच में क्या है यहाँ पे? There is attraction between the nucleus because we have this is not charges, positive and positive are phases. Once again I'm saying between the nucleus we have attraction. Because we have attraction, this will be stable. Because it is stable, it will be having lower energy. Now let us talk about ABMO. Now see, ABMO भी बहुत सारे लोगों को लग रहा होगा, sir, it is also symmetrical. I will say no, it is not symmetrical. Please see here. If I am here, rather let me take something else. If I am here and I move rightwards, I get negative phase. But if I move in the opposite direction, I get positive phase. That means the phases are different in different direction. So obviously it is not symmetrical. All of you got this? Yes or no? Please tell me. हाँ जी बताएं. This is unsymmetrical. Guys. अरे
Yes,
बोलो
sir.
भाई.
Yes, sir.
What about others? आलिया, सिद्दीका.
Yes,
अब
sir.
बताइए, टेल मी, इन दोनों के बीच में अट्रैक्शन होगा या रिपल्शन होगा? पॉजिटिव और नेगेटिव के बीच में अट्रैक्शन होगा या रिपल्शन होगा?
Repulsion.
रिपल्शन होगा. व्हाट अबाउट अदर्स? सिद्दीका, यासिर.
Repulsion.
क्यों? पॉजिटिव और नेगेटिव के बीच में तो अट्रैक्शन होना चाहिए ना? नहीं. क्या ख्याल है मरियम, सिद्दीका, आलिया?
I think it's attraction.
Sorry, Alia, what you are saying?
Attraction.
Attraction. Mariam, what would happen? Attraction or repulsion? Mariam?
Repulsion.
Repulsion ही होगा. देखिए,
Attraction.
attraction होगा. देखिए, यही तो हम बोल रहे इतनी देर से. ये what are these positive and negative? Are they charges?
No.
हाँ.
They're the
तो सर
phases.
लॉजिक ही गलत है सर. आपको चार्ज है ही नहीं तो क्या अट्रैक्शन रिपल्शन यहाँ पे है ना? वी आर नॉट गोइंग टू लुक एट दिस पॉजिटिव एंड नेगेटिव टू से attraction or repulsion. We will look at where is the positive charge in nucleus. It is in atom. It is in the nucleus. Right? So this is positively charged. This is positively charged, right? Both of these are positively charged, and in between there is no electron. So both of them will be repelling each other. ठीक है? तो positive negative देखे charge नहीं समझना है. So here we are having repulsion. This will be unstable because it is having repulsion, unstable, and it will be having higher energy. Okay, everything clear? Yes or no, please.
But I said repulsion, right?
आपने रिपल्शन तो बोला था, फिर आपने अट्रैक्शन बोल दिया.
Because
आपने रिपल्शन यहाँ से देख के बोला, इधर अट्रैक्शन तो उधर रिपल्शन, इधर सिमेट्रिक तो उधर अनसिमेट्रिक, है ना? ठीक है, तो इस वजह से तो हमने बोला पॉजिटिव नेगेटिव. जवाब ये होना चाहिए था रिपल्शन बिकॉज देयर इज नो इलेक्ट्रॉन इन बिटवीन द न्यूक्लियाई. If there was electron, the nucleus will be attracted this way, this nucleus will be attracted this way, and there would have been attraction between the nucleus, है ना, overall. ठीक है, पॉजिटिव नेगेटिव आपने भी तो फिर अट्रैक्शन नहीं हुआ. चलिए, those who have done writing, very good. Those who have not written, very good. Please write it now. आप कुछ लग रहा है कि कुछ पढ़ रहे हैं, कुछ पढ़ाई हो रही है ना? 10th क्लास तक तो खेल होता है आप लोगों के साथ. जी क्या ख्याल है? आलिया, सिद्दीका, यासिर, मरियम, बताएं. पढ़ाई तो मेन आपको लग रही होगी फिजिक्स में, जो बात है फिजिक्स में लग रहा होगा. जब आप लोगों ने आप हैव यू डन दोस थिंग्स लाइक प्रोजेक्टाइल मोशन हो गया क्या? प्रोजेक्टाइल मोशन हो ही गया होगा ना? यस सिद्दीका, आलिया बताएं.
यस सर.
हो गया प्रोजेक्टाइल मोशन. ओके, फिर वो एंगल ऑफ रोड जो मतलब ये रहता है, एंगल ऑफ डिप्रेशन, पता नहीं क्या बोलते हैं उसको. when there is a curved road then it has to be in a particular angle, right? वो पढ़ा है आप लोगों ने? नहीं पढ़ा अभी तक?
यस सर.
पढ़ा है ना? चले, हो गया. टेल मी गाइस, एवरीवन डन?
yes,
Can I
sir.
move forward? Okay. Anyone still writing? Please let me know. Anyone still writing? No, ना? ठीक है, चलिए. Right, next. टू पी mixing. ठीक है, 2p mixing. Now, in 2p mixing there can be two cases. The p orbital can mix like this on the internuclear axis, or they can mix like this above and below the internuclear axis. Correct है guys? Yes or no? Please tell me. All of you, right? Yes or no? अरे बोलो भाई. There are two cases ना. They can combine on the internuclear axis, or they can combine above and below the internuclear axis. We will take the case one first of all. Atomic orbitals combine on internuclear axis. On internuclear axis. So let me make the 2p. One, and here we have 2. Just a second, guys. Okay. So again, we are going to take the two cases. थोड़ा इससे हम उधार ले लेते हैं. Okay, so first of all, see, both of these are going to combine. These lobes are going to combine. Okay, and when they are going to combine, they will again make a very fat type of thing like this. ठीक है, इस तरह का. So this is between these two lobes. when these two lobes are going to combine. And when they are combining, they will bulge out, and this will remain as it is like this. These are the remaining ones, है ना? ये हम बना रहे हैं यहाँ पे, be like this. एक सेकंड इसको छोटा करके हम यहाँ से ले लेते हैं, तो बनाना बड़ा ही दिक्कत हो जाता है. Wait a second, guys. Okay, so let us suppose this was like positive and positive phase. ठीक है, तो यहाँ पे negative और यहाँ पे negative होगा, है ना? Positive positive they combine, and the nuclei are here and here, suppose, and here. Okay, and when they are having opposite phases, जब देखिए same phase था तो both of them combined and बहुत मोटा हो गया बीच में, है ना? And when the opposite phases will be there, so obviously what is going to happen if I am having this as the nuclei, this is the nucleus, so see, one of them will be cancelling out, right? एक क्या हो जाएगा, cancel out हो जाएगा बीच वाला, and the other side one, the other side one will be as it is. थोड़ा सब्र रखिए जरा, हम बता रहे हैं आप. ठीक है, so see, this will be negative, ये आप रख लीजिए positive. So both the phases were different, so they cancelled out, है ना? And I am showing small lobes because to represent that they have cancelled out, है ना? So essentially there is no electron, but I am showing negative and positive to just show what was there and what has cancelled out. If this was not negative, this would be positive, and this would be negative. Correct, guys? Yes or no? Please tell me. No problem, na? Tell me. Mariam, Yasir, Siddiqa.
Yes, sir.
Okay. Now another thing that is very important is the naming. So tell me, atomic orbitals are combining on internuclear axis. So sigma, क्या हो जाएगा ये? Sigma. And this sigma, this is obviously this first of all BMO, bonding molecular orbital. This is ABMO, anti-bonding molecular orbital. This BMO, it is going to be sigma 2p because it is made by the p orbital, and this will be sigma star because it is anti-bonding, and it is made by 2p, so it will be sigma star 2p. हाँ जी बताएं, कोई दिक्कत?
No, sir.
No, na? And if you look at the properties here, that whether it is symmetrical, stable, and lower energy, so obviously BMO is going to be lower in energy and it will be stable. Let me just talk about the symmetric. So BMO, this is what is going to be symmetric. As you can see, if I am here, symmetric means you take the center and you move upward. You will get the same thing downward. You move on the right, you will get the same thing in the left also. Okay? If you move right, you will get positive phase, positive phase, positive phase. If you move even more, you will get negative phase. Similarly, if you move the same distance in the opposite direction, you will again get positive, 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 and then negative. But this ABMO is still unsymmetrical here. And rest of the properties is similar as that of this ABMO of sigma 1s star. Chaliye, let us look at the second case. आगे बढ़े. Can we move forward, guys? Yes or no? Please tell me. बोलो भाइयों.
Yes, sir.
ठीक है. Case 2. सिर्फ मरियम बच गई है बोलने में, बाकी लोग चुप हो गए. एक हम बोल रहे हैं बस. Case 2. Atomic orbitals combine above and below internuclear axis. ठीक है, तो ये था हमारे पास. इसको पलटी मारा देते हैं थोड़ा सा. रोटेट व्हाट 90 degrees and then थोड़ा सब्र रखिएगा. थोड़ा कलाकारी हम कर लें यहाँ, बिठाना नहीं था भाई। ये हो जाएगा थोड़ा छोटा और ये हो जाएंगे थोड़े बड़े, दोनों आ जाएंगे इधर, एंड देन one more here. Now here we have the two atomic orbitals which are combining above and below the internuclear axis. ठीक है, ये आपका यहाँ पे न्यूक्लियस है, ये आपका यहाँ पे न्यूक्लियस है, these are moving this way, है ना, and this is your internuclear axis actually, right? So the lobes are not on internuclear axis, that they are above and below. चलिए, उसके बाद let me take the addition subtraction वाला, यहाँ से अब तक आप लोग को थोड़ा अंदाजा हो जाना चाहिए कि what is going to actually happen. So what is going to actually happen is that, see, here we are not having any electron density, ठीक है ना, so both of these are going to combine और फिर उसी तरह से बिल्कुल क्या बना लेंगे, a big bulge like this, ठीक है, and a similar bulb below the internuclear axis. What is this? This is INA. This is INA. So obviously this would also be positive and this would also be positive. This is also positive and this is also, sorry, no, my bad. ये positive हुआ होगा, ये negative हुआ होगा. So this will be below, here will be negative and negative. ठीक है ना, ऊपर के दोनों lobes positive और नीचे के दोनों lobes negative, then only there would have been a same phase addition. अगर subtraction की बात आए, so the subtraction will look very ugly. Subtraction is going to look very ugly. It is going to look something like this. Please see. They are going to combine and then they are going to cancel things out, right? So कुछ जितना combine होगा, that will be cancelled out. Something will be remaining like this. है ना? Some part of the lobe will be remaining like this. And this is one of the lobe. And similarly, some part will be remaining like this for the other atoms, atomic orbital. Okay? And this is your internuclear axis. Okay, so obviously this would have been positive, this would have been negative. That is why they cancelled in the middle part. This would have been negative and this would have been positive. And the nuclei would be here and here. Okay, nuclei will be here and here. So you can see that there is no electron density in between the nuclei. But if you look the nuclei of these two, so one of the nuclei will be here, the other nuclei will be here. I'm showing that there is a difference here, but actually both of these will be very close to each other. And also this positive, this nuclei will be attracted this way. This also will be attracted this way. This will be attracted this way and this will be attracted this way. So essentially what is happening, if I take the vector, it is both of them are getting attracted towards each other. Now, if you look at the symmetric and the unsymmetric nature in this case, also one more thing. पहले नाम लिख लेते हैं. So this is obviously ABMO and this is BMO. But since the atomic orbitals are combining above and below, we call them pi. So this is going to be pi of what? 2p. And this is going to be the pi star of 2. Now let us talk about symmetric and unsymmetric. Let us take the middle part of the BMO, pi 2p. If I go above, I get positive phase. If I go down, I get negative phase. So obviously this pi 2p, it is not symmetric in nature. So this is unsymmetrical. And the remaining properties, that is stable, it is having lower energy, all of them are true. And this is going to be symmetrical. Why symmetrical? As you can see, if I go, I'm having green here in the middle. If I go on this side, I'll get negative if I go just the opposite side, I get again negative. So it is obviously symmetrical. चलिए, इतना सबको समझ में आया ना? जल्दी बताएं.
Yes.
Yes, sir.
ठीक है, सबने लिख लिया? Did everyone write?
No, sir. One second.
लिखा नहीं है आप लोगों ने अभी? चलिए ठीक है, उसको आराम से लिखिए. क्या ये नहीं लिखा या कुछ नहीं लिखा? कहाँ से स्क्रॉल अप कर लिया बताएं जरा.
No,
Tell me,
sir. I'm
Siddhika.
just on the case.
केस 2. ओके ठीक है.
Done, sir.
ओके, सो दैट इज इट फॉर टुडे. ठीक है, एंड बेसिकली चलिए उससे पहले ना कुछ हम सवाल कर लेते हैं आप लोगों से, तो फिर आप लोगों को थोड़ा याद रहेगा. ठीक है, राइट अ क्वेश्चन. Consider z axis as INA. Consider z axis INA. What are the MOs, molecular orbitals, formed by linear combination of atomic orbitals of following? ठीक है, तो इंटर न्यूक्लियर एक्सिस कहां पे है बताएं जरा. इट इज इन दी z एक्सिस. सही है? ठीक है.
Yes.
Yes, sir.
Now let us see. If I have number A, if I have 2pz, wait a second. If I have 2pz and 2pz, ठीक है. Now if I am having pz, then the lobes will be on which axis? Lobes will be on which axis? x, y और z. pz के lobes कहाँ रहेंगे? अरे बोलो भाई, pz है तो lobes कहाँ रहेंगे? x में, y में या z में? No one. सब भूल गए. यासिर, सिद्दीका, मरियम, आलिया and Abdullah. Where will be the lobes? No idea, guys. अरे ऐसा नहीं होना चाहिए ना. सिद्दीका बोलिए. Yes, Siddhika. If I am having the pz orbital, array, please flip your pages now, guys, who have studied at least with me the atomic structure. Flip your pages, go to the p orbital, p subshell, and see px, py, and pz. उतना तो कर सकते हैं जिन लोगों ने पढ़ा है हमसे atomic orbital. If you have studied the atomic structure ना, वहां पे atomic orbitals पढ़ाया है हमने, shapes पढ़ाए हैं. नहीं, ये तो बहुत खराब बात है ना. आंसर कीजिए. सिद्दीका, टर्न योर माइक ऑन. सिद्दीका, प्लीज टर्न योर माइक ऑन. यस. नाउ टेल मी, px अगर होता है, then the lobes are on which axis? px में. Yes, Siddhika. If you have the px orbital, no idea, say yes or no ना सिद्दीका. इतना चुपचाप बैठने से कोई फायदा नहीं. Tell me, I don't know, sir. You are not saying anything.
X.
Siddhika, what? Sorry?
On X axis.
On x axis. If it is py, then the lobes will be on.
Y.
If it is pz, then it will be on.
Z.
It will be on
Z.
pz. It will be on the z axis. अरे क्या हार्ड सवाल तक जवाब क्यों नहीं दे रहे थे फिर आप लोग?
I wasn't sure, sir.
See here, guys. The 2pz and the 2pz, the lobes will lie on which axis? Lobes will lie. Turn your mic on and tell me now. Lobes will lie on which axis? मरियम, आपको नहीं आया?
Y axis.
y एक्सिस, px में if it is px तो नाम क्यों है इसका px? Because the lobes are on x axis. py में कहां पे होंगे? y एक्सिस में. और pz में कहां होंगे बताइए? यस मरियम?
Z.
z एक्सिस. ठीक है, सिंपल है चीजें, ठीक है ना, कुछ डिफिकल्ट नहीं है चीजें, सिंपल है ना. जो लॉजिक कह रहा है पहले उसी को आप जवाब देने की कोशिश करें. px है तो x में होना चाहिए, नहीं होगा तो फिर आप जवाब दीजिए सर फिर x में क्यों नहीं रखा, नाम क्यों मिला फिर इसको px. ठीक है, ट्राई टू जस्ट यूज योर माइंड, है ना. आई एम टेलिंग ऑल ऑफ यू गाइस, ट्राई टू यूज योर माइंड एंड देन कोई लॉजिक होना चाहिए बस आपके आंसर का याद करने के लिए. तो हम नहीं भी कर रहे हैं. px है तो px कहाँ पे होगा? x एक्सिस में होगा. ठीक है, अगर नहीं हुआ तो फिर आप सवाल करेंगे नहीं सर नाम से तो लग रहा है कि x एक्सिस में होना चाहिए, क्यों नहीं है फिर x एक्सिस में. ठीक है, चलिए. नाउ आल्सो द इंटरन्यूक्लियर एक्सिस कौन सा है बताएं? व्हाट इज द इंटरन्यूक्लियर एक्सिस? इसमें भी शांत है. अरे सवाल में लिखा हुआ है, माइक ऑन करें फिर बोले ना क्या एक्सिस है, हाँ या ना. There is a reason I ask you to repeat things. इंटरन्यूक्लियर एक्सिस कौन सा है? x, y या z? z है. ये नहीं दिख रहा है क्या आप लोगों को? मरियम, सिद्दीका, यासिर, अब्दुल्ला. कंसिडर z एक्सिस एज INA, इंटरन्यूक्लियर एक्सिस. हाँ जी बताएं. सिद्दीका एंड मरियम, आलिया. आलिया ने
Yes,
तो
sir.
जवाब दिया. अब दोनों चीजें सब लोग प्लीज बोले. Lobes are on which axis? Lobes of PZ are on which axis?
Z axis.
Z axis. सिद्दीका को समझ में आया? आलिया, yes or no, please tell me.
Yes, sir.
Lobes are on which axis?
Z axis.
और INA कौन सा है? What is the internuclear axis?
Z axis.
Z axis. तो कॉम्बिनेशन कहां पे होगा? बताइए. एटॉमिक ऑर्बिटल्स कंबाइन कौन से एक्सिस पे करेंगे? अब देखिए, खुद से देखिए. आपने बनाया इंटरन्यूक्लियर एक्सिस, इसको बोला आपने Z एक्सिस. ऑब्वियसली जो PZ होगा कुछ इस तरह से होगा, हाँ या ना? अरे बोलो भाई.
Yes, sir.
Now if they are going to combine, तो कॉम्बिनेशन कौन से एक्सिस में हो रहा है?
Z.
Now when they are combining on the same axis, है ना, इंटरन्यूक्लियर एक्सिस में जब कॉम्बिनेशन हो रहा है तो क्या बॉन्ड मिलता है? सिग्मा या पाई? What bond is made? Sigma और पाई. If the combination happens on internuclear axis, तो कौन सा जी?
Sigma.
सिग्मा. ठीक है, तो सुनिए देखिए. अब ये दोनों कैसे मॉलिक्यूलर ऑर्बिटल बनाएंगे? दो बनाएंगे, एक तो BMO बनाएंगे और एक ABMO बनाएंगे. ठीक है, जो BMO होगा दैट विल बी सिग्मा मेड बाय 2PZ. जो ABMO होगा दैट विल बी आल्सो सिग्मा बट स्टार बिकॉज इट्स एंटी बॉन्डिंग मेड बाय 2PZ. समझ में आया नहीं आया बोले? ऑल ऑफ यू गॉट दिस? यस और नो, प्लीज टेल मी गाइस.
Yes, sir.
Yes, sir.
पक्का समझ में आई बात? ठीक है, देखिए ये तो हो गई बात किसकी? 2PZ की. सॉरी. उसी तरह से मान लीजिए आपके पास अगर होता 2PX एंड 2PX. ठीक है, तो ध्यान दीजिए जरा. अब मेरी हिम्मत खत्म हो गई है पूछने की, आप लोग दिमाग लगा नहीं रहे. ये Z एक्सिस है. ठीक है, अब बताइए ये PX होगा या फिर ये PX होगा? A और B कौन सा PX होगा? A और B कौन सा होगा PX? A या B? ठीक है, यासिर आगे बताएं. बाकी लोग, मरियम, यासिर, सिद्दीका. यासिर ने कह दिया. मरियम, आलिया, अब्दुल्ला, सिद्दीका, टेल मी A और B which will be PX?
B.
क्यों मरियम, थोड़ा आप ये बता दें क्यों? Why you are saying B? Because हिम्मत करें थोड़ा सा. हाँ जी मरियम.
internuclear axis
हाँ ठीक है,
Z
इंटरन्यूक्लियर एक्सिस इज
axis.
Z। हाँ फिर अरे भाई ठीक है, चलो कोई बात नहीं। जिन लोगों ने कुछ कुछ आंसर दिया है उल्टा सीधा, प्लीज सुने यहाँ पे। इफ आई एम सेइंग दिस इज Z एक्सिस, तो ये लोब्स, तो ये जो A होगा, दिस A इज 2pz। ये तो 2px हो ही नहीं सकता ना। फिर भी लोगों ने क्या जवाब दिया, A होगा। आलिया A कैसे हो जाएगा? अगर Z एक्सिस में लोब्स हैं तो इट विल बी pz ना।
Yes, sir.
हाँ आलिया,
Yes, sir.
ठीक है। तो B होगा क्या? B विल बी योर, सॉरी, B विल बी योर 2px। और इसी तरह का एक 2px और आ जाएगा, है ना। एंड द इंटरन्यूक्लियर एक्सिस इज व्हाट, x y z, सारे के सारे क्या होते हैं एक दूसरे से 90 डिग्री, ठीक है। नाउ द लोब जो है वो कहाँ है? अबव एंड बिलो कॉम्बिनेशन हो रहा है, सही है हाँ या ना?
Yes, sir.
तो कौन सा बॉन्ड बनेगा? व्हाट टाइप ऑफ बॉन्ड विल बी मेड, सिग्मा और पाई?
Pi.
पाई। एक तो बीएमओ बनेगा और दूसरा एबीएमओ बनेगा। क्या क्या? यहाँ बनेगा पाई 2px और यहाँ बनेगा पाई स्टार 2px, ठीक है। बात समझ में आ रही है सबको? हाँ या ना, जल्दी बताएं। मरियम, सिद्दीका एंड ऑल ऑफ यू
Yes, sir. Yes.
ठीक है। चलिए, और देखिए एक चीज आपको हम बता देते हैं, व्हेन वी आर टॉकिंग अबाउट, सी दिस इज द Z एक्सिस ना, और जो s ऑर्बिटल होगा इट इज कंप्लीटली सिमेट्रिकल। सो नो मैटर व्हाट द इंटरन्यूक्लियर एक्सिस इज, s तो स्फेरिकल है, वो हमेशा कैसा बॉन्ड बनाएगा? इट विल बी ऑलवेज ऑन द इंटरन्यूक्लियर एक्सिस। तो s कैन ओनली मेक सिग्मा बॉन्ड्स, ठीक है। s कैन ओनली मेक सिग्मा बॉन्ड। अगर यहाँ पे सुनिए, देखिए तो s के लिए तो क्या है, ओनली सिग्मा। p में आपके पास दो केसेस है, p में आपके पास दो केसेस है, INA एंड एक्सिस इज सेम। यानी कि अगर आपके पास Z एक्सिस है तो जो P है वो भी PZ है, ठीक है। INA और एक्सिस क्या है, सेम। INA एंड एक्सिस आर डिफरेंट, ठीक है। INA और एक्सिस सेम है। फॉर एग्जांपल INA आपके पास क्या है, Z, और आपके पास ऑर्बिटल क्या है, PZ, ठीक है। INA है आपके पास मान लीजिए X, और आपके पास ऑर्बिटल है PX का कॉम्बिनेशन। तो इन केसेस में यू विल गेट सिग्मा। और अगर डिफरेंट हो जाए, फॉर एग्जांपल INA है आपके पास Z और ऑर्बिटल मिल रहा है आपको PX कंबाइन करने के लिए, इंटरन्यूक्लियर एक्सिस है आपके पास Y, और जो एटम, सॉरी, और जो ऑर्बिटल मिल रहा है दैट इज PZ, ठीक है। तो इफ द इंटरन्यूक्लियर एक्सिस एंड द एक्सिस आर डिफरेंट देन यू आर गोइंग टू गेट पाई, ठीक है। और दोनों के केसेस में BMO ABMO दोनों मिलेगा। चलिए, please write this down if you have not written this. And that's it for today. We are going to meet again on next